All right, we're going to take a look at 23 through a few. I think through 34 is what we'll go through. All right, 23, square root of negative 40. Well, we have to break down that negative 40 into its prime factorization. To do that, if we do a factor tree, I can think, 4 times 10. And 4 breaks down to a 2 times 2. 10 is going to break down to a 2 and a 5. So we've broken it down to its prime factorization. So this is nothing more than a negative 1, because there's the negative piece in it, times 2 times 2 times 2 times 5. And so what we want to do is we want to find a pair in order for it to come out. Well, there's only one pair. So that pair will come out as a 2. The negative 1 will always come out as an imaginary number. So cleaning this up, we have 2i on the outside, and on the inside we have 10. So 23, the answer is 2i root 10. 24, we know that what we have here, a to the third means a times a times a. B to the sixth means b times b times b times b times b times b. Now, it takes a pair to come out. So here's a pair, so it's going to come out. Here's a pair of b's, comes out. Another pair is going to come out. And another pair is going to come out. So what does that leave us on the outside? It leaves us an a, b to the third, and who's left inside? A single a. So that answer to 24 is ab cubed root a. Now if we look at 25 here. So 25 has square root of negative 80 a squared. Well, we have to break 80 down as the first step we have to do. So I think, okay, 8 times 10. 8 can go further, 4 and a 2. That 2 cannot go any further, it's prime. The 4 can break down to a 2 and a 2. Come back to the 10. The 10 can break down to a 2 and a 5. That's as far as it goes. So this guy ends up being, we have a negative, so you have a negative 1. And then you have times 2 times 2 times 2 times 2 times 5. Then you have an a times a. Now all we're doing, since we've broken it down, is look for a pair. Well, first of all, I do know that negative 1 is going to come out as an I. Here's a pair of 2's, comes out. Another pair of 2's comes out. Not a pair of 5's, but we do have an a that can come out. So clean it up, we have 2 times 2, which is 4. Then an a, we have an I right here, and then just a 5 left over. Right? Now, some places will write this as 4a root 5 and then the I out here. I'm not really concerned as long as you understand when you have a negative, it's a negative 1 inside, it's going to come out as an imaginary number. That's all I'm worried about for right now. And let's look at the next page, 26. Square root of 128. It's pretty large. We're going to have to break that down. I see 64 times 2, if I just break it in half. 64 is 8 times 8. That 8 breaks to a 4 and a 2. That 2 can't go any further. That 4 is a 2 and a 2. Come back to this 8. I got a 2 and a 4. That 4 can go to a 2 and a 2. Now, I got to be careful here because I got a lot of 2's, don't I? Let's see how many 2's we have. I have 1, 2, 3, 4, 5, 6, 7. I see 7 2's. 1, 2, 3, 4, 5, 6, 7. Takes a pair to come out. That pair is coming out. Pair coming out. Another pair will bring them way out there. So I have 2 times 2 times 2, which is 8. And then I'm left behind with 2. 8 root 2 is the exact same thing as the square root of 128. They both have the exact same value. It's just 8 root 2 is considered simplified, just like we simplify fractions. Oops, come on down. Oops, we went too far. All right, square root of negative 600. Well, if we break 600 down, it's not as bad as it seems. A 3 times 200 is how I'll start. 3 is prime. 200 goes to 100 times 2. That's a 10 times 10. 2 and a 5. That goes to 2 and a 5. And it's negative, so we have a -1. I have a 2, 2, and a 2. 2, 2, and a 2. I have a 3, and I have 2 5s. All right, let's bring out. -1 comes out as an imaginary number. 2 comes out. That 2 doesn't, that 3 doesn't. Mr. 5 comes out. So on the outside, I have 10i root, what's left? 2 times 3 inside? 10i root 6 for number 27. Number 28. It says a cubic root. That means you need 3 in order for somebody to get out of the house. You have to come out as triples to come out, triplets, whatever you want to say. So I have 8 of the 9th. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. B to the 6. 1, 2, 3, 4, 5, 6. So it takes 3 to come out. So those 3 are going to come out. Now remember, when they come out, they just come out as 1. Comes out as 1. Comes out as 1. Wow. Now look at the B's. Takes 3 to come out. Another 3 to come out. So I have a cubed, b squared. Am I left with anything on the inside? No. Technically, I'm left with the square root of 1, which is just 1. So this right here is my final answer. Basically, it comes out a perfect square. Like square root of 25 has 2 5s. They both come out, and there's nothing left on the inside. So we get rid of the square root symbol. Technically, there's a 1 in there. 29, cubic root. Now we have a 16. If we break 16 down, 16 breaks down to a 2 and an 8, 2 and a 4, 2 and 2. So this is the cubic root of a 2 times 2 times 2 times 2, x, 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 excuse me, y, 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 y. A lot of talking going on here. So cubic, I need 3. 2 comes out. 3 x's come out. 3 y's, be careful, that was a little messy. Then these 3 y's come out. Excuse me. You do not have to draw these arrows I'm drawing at the top. And my handwriting is pathetic. Sorry about that. So let's clean up now. 2x, y, which is y squared. Draw your little cubic root. Make sure it stays inside there so it doesn't look like it's y to the 23rd power. Inside, I'm left with a 2, an x, and I have a y squared there. So it's 2xy squared, cubic root of 2xy squared. Interesting answer. Number 30, fifth root. That's going to take 5 to come out. Now you should start being able to sort of see things because I can see I have 6 x's, group of 5. 1 x is going to come out, 1's going to be left behind. But let's write it in case we don't. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, we're trying to learn, but we do want to start seeing things. So as I was saying, it's going to take 5 of these x's. So I know one of them comes out, and you can see 1 is left behind. For the y's, 5 of them come out. 1, 2, 3, 4. Do you notice that I circled 6? Silly me. So there's 1, 2, 3, 4, 5. So another y comes out. So we're left with x, y squared, left behind with a single x and a y squared. Now, do you notice something that's not right? Notice this, you need a little fifth root right in there. So it's xy squared, fifth root of xy squared. Number 31. Oh my goodness, what do we have here? A fourth root of 12,960. How am I ever going to do that? Now, if you need to grab a calculator and break it down, that's perfectly fine. There's nothing wrong with that. Let's see if we can do anything here. Or I could grab a calculator. I don't really have anything. Guess I could pull another screen up, or I could grab my phone if need be. So you have to think, what do you want to divide it by? Well, I think the most obvious would be 2, but do you see anything else maybe bigger? Well, let's just do it by 2, I guess, to start us off. So if we divide by 2, we break it down, let's see, 12,960 in 2, that'll give us what, 6,480. Okay. Now, if we divide him by 2, what are we going to get? A 3,240. And again, you can be using a calculator. Let's break it down by 2 again. 11620. Okay. Now, I'm going to go ahead and break this to a 10. And I could have done that back long ago. It would have been a little bit easier, but that's okay. We'll do it now. Into 162. And 10 will go to a 2 and a 5. 162. Well, let's divide that by, you can just divide it by 2 again would be fine. 81. Ooh, 81. 81 I recognize as a 9 and a 9. And now a 3 and a 3. A 3 and a 3. Now it's going to be a little bit, we're going to have to try and take care of quite a few things. Let's list it right here. Let's put him right here where we can see everything. I see a 1, 2, 2 of them, 3 of them, 4 of them, 5 of them. That's it. So I got 1, 2, 3, 4, 5. All right, let's do the 3s now. See, 1, 2, 3, 4. 1, 2, 3, 4. And what else do I have? You have a single 5 here. And I believe that's it. Okay, let's see what we have now. 2 comes out. 2 was, hold on a second. Oh, that's why it's going to help. Let's back up, because we need 4. Notice it's a 4th root. This is a 4th root. Okay, so we have 4 2s. That comes out. 4 3s. That comes out. And that's it. So now we're left on the outside of a 6, 4th root. And we're left with a 2 and 5 here, 10. So that's what we'll get for 31. We'll get 6, 4th root of 10. All right, a few more here. All right, we're just going to simplify these fractions. So what I need to do, I need to first rewrite this as 8 plus or minus square root of that negative 8. 8 breaks down to 3 2s and a negative 1. So it is going to give us a 2i root 2. Again, break 8 down to a 2 times 2 times 2. One pair of 2's is coming out. The negative 1 comes out as an I. All over 2. Now we look at this, this, and this. And we say, hey, is there something by which they all can be divided? And the answer is yes, a 2. So 8 divided by 2 is 4. 2 divided by 2 is 1. 2 divided by 2 is 1. So we have 4 plus or minus 1i, which is just I, root 2, all divided by 1, which is, boom, just itself. So it's 4 plus or minus I root 2. Coming to this one. We have 6 plus or minus square root of negative 27. So you know when I is coming out. 27 is a 3 times 3 times 3. So you can have a single 3 come out and 1 left behind, all over 3. Now I look at this, this, and this and say, what can they all be divided by? The answer is 3. 3 divided by 3 is 1. 1. 6 divided by 3 is 2. So this gives me 2 plus or minus I root 3 over 1, which just goes away. And the final one here, 9 plus or minus the 40 square root of 45. No negatives in it, so there's no i's. So we have 9 plus or minus Well, let's think. 45. 3 times 3 times 5. So a 3's coming out. 5's left behind over 6. So I'll look at the 3, 6, and 9 and say, what can they all be divided by? They all can be divided by 3. 6 divided by 3 is 2. 3 divided by 3, 1. 9 divided by 3, 3. So we get 3 plus or minus 1 root 5, which is just root 5, because 1 times anything is itself, all over 2. So there we have those problems. Hopefully that'll help you.